The easiest way to solve this integral is to substitute out this one. So what I'm going to do is to let a variable of my choice, I am going to let, let's say why not, to be equal to x raised to the power x raised to the power x. This one continues until infinity, right? So when we have this, then we can write y in terms of y and x. So y is going to be equal to x. That is the first one. That is this one. This one is raised to the power y as well, because everything here is y as well, because this one is infinite powers of x. So y can be expressed as x raised to the power y. So here what we need to do is to find an expression for the ln of x, find an expression for x dx, and change in limits, change of limit. So when we do this, then we can take the integral into the y wall completely, right? So after doing this, let's try to find the ln of x. So this is going to be taking the ln on both sides of this. That is going to be the ln of y, and that is going to be the ln of x raised to the power y. So that means applying the power rule of logarithm, y times the ln of x. This is equal to the ln of y. So we can find the ln of x, and that is equal to, dividing both sides by y, is going to be 1 over y times the ln of y. Cool, so we have found an expression for the ln of x in terms of y. Next is to find x in terms of y. So let me switch colors, why not? So here we are going to apply the power rule of logarithm, and that is going to be the ln of y. This is raised to the power 1 over y, and that is going to be equal to the ln of x. So here we can isolate x by taking the exponent on both sides. So e raised to the power ln of y, this is raised to the power 1 over y, and this is equal to e raised to the power the ln of x. So this isolates x to be equal to y raised to the power 1 over y, because these ones will cancel, right? Okay, so that is an expression for x in terms of y. So we can check that. Now, to find an expression for dx in terms of y and dy, we have to differentiate. So we have to differentiate this one here. Alright, cool. So differentiating that is the ln of x, this is equal to 1 over y times the ln of y. So differentiating, that is going to be ddx of the ln of x, and that is going to be equal to the ddx. So we are differentiating this one with respect to x. I'm sorry, this one is y. But because y is a function of x, we have to differentiate the variable y with respect to x, because y is a function of x. That is what we have here. This is what we call the implicit differentiation. So differentiating 1 over x, ln of x is 1 over x, and differentiating this one using the product rule. So I'm going to keep 1 over y constant, and I'll differentiate ln of y, which is 1 over y, plus I'm going to keep the ln of y constant, and I'll differentiate 1 over y, which is negative 1 over y squared. All this one is multiplied by dy dx. Alright, cool. But we can replace x, right? Because we want everything in terms of y. X is y raised to the power 1 over y. So this one is 1 all over y raised to the power 1 over y. And this is equal to, this is 1 over y squared minus 1 over y squared times the ln of y. This one is multiplied by dy dx. Next, we can factorize 1 over y squared out, make things simpler, and that is going to be 1 minus the ln of y. And this is multiplied by dy dx. This is equal to 1 over y raised to the power 1 over y. Now let's isolate dx here. Why not? So this one is going to be, so dx is going to be equal to y raised to the power 1 over y. This is multiplied by 1 minus the ln of y dy. But what is at the bottom here is y squared. Alright, so this is an expression for dx in terms of y and dy. We are done. Now the change in limits. So the change in limits, let me switch colors again. So we are going to use this one to find the change in limits. So the change in limits is that x is equal to y raised to the power 1 over y So after doing this, now what about the lower limit for x? This is 1 over 4 and the upper limit is the square root of 2. So x is 1 over 4 for the lower limit, and that is equals to y raised to the power 1 over y. But 1 over 4, I can write 1 over 4 as 1 over 4 can be written as 1 over 2, and this one is raised to the power 1 over 2. So 1 over 4 is written as 1/2 raised to the power 2, and this is equals to y raised to the power 1 over y. So that implies that 1/2 squared, but squared can be written as 2 can be written as 1 over 2. And this is equal to y raised to the power 1 over y. So now comparing both sides, what will be the value of y for which this equation will be true? So by comparison, we can see that y here is equal to 1/2. So when y is equal to 1/2, this equation on the right hand side is equal to this equation on the left hand side. So that is the lower limit for y. What about the upper limit? So the upper limit, x is equals to y raised to the power 1 over y. The upper limit of x is the square root of 2, and that is equals to y raised to the power 1 over y. Alright, so square root of 2 can be written as 2 raised to the power 1 over 2. And this is equals to y raised to the power 1 over y. So by comparison, what would be the value of y here? So 2, so the bases are the same, and then the powers are also the same. So that means 1 over 2 is equals to 1 over y, and therefore y here is going to be equal to 2. So the lower limit for y is 1/2 and the upper limit is 2. Now that we have this, we can take the integral entirely into the y world. I is going to be the integral now from 1/2 to 2 of what? Of 1 over x of 1 all over x. But what is an expression for x in terms of y? So that is y raised to the power 1 over y. This is y raised to the power 1 over y, and this is multiplied by this one, which is represented with with y, I'm sorry. That is y, and that one is multiplied by ln of x minus 1. So ln of x, we have found an expression for ln of x in terms of y, and that is this guy. That is this. That is 1 over y times the ln of y. This is multiplied by 1 over y times the ln of y minus 1. And this one is multiplied by dx. An expression for dx in terms of y and dy is this one here. That is y raised to the power 1 over y multiplied by 1 minus the ln of y, like this, dy. And this one is divided by y squared. There's dy here, beg your pardon. Alright, cool. So I here is going to be equal to, there's going to be some cancellation. Let me change color and cancel them for you to see. Y is going to cancel y. We have y raised to the power 1 over y is going to cancel this one on top here. And now what is left? So there's going to be some reordering, which I will do here. So the integral from 1/2 to 2 of 1, all this one is divided by what is left at the bottom here is the ln of y minus 1. This is what is left. And now what is left here is going to be what? So here, permit me to factorize -1 out of here, and that is going to be negative into the ln of y minus 1, like this. This one is divided by y squared, and then dy. Alright, so I is going to be equal to the integral from 1/2 to 2. Now we see that there's going to be another cancellation, a big one. So this one is going to cancel this one out nicely, and what is left is -1 over y squared dy. Beautiful. Now integrating -1 over y squared is going to be positive 1 over y. So take the limits of integration from 1/2 to 2, and this is going to be equal to 1 over 2, putting in the limits minus 1 over 1/2. So I here is going to be 1 over 2 minus 1 over 1/2 is 2, and that is equal to -3 over 2. So I here evaluates to negative 3 over 2. And this one agrees with the answer that MIT gave for this turning integral. So this one integrates to negative 3 over 2. And that is the beautiful answer to this beautiful integral. Yeah, so that is how I solve it. If there's an easier way to solving this, please leave a comment in the comment section and let me know what you think. And if you enjoyed this video, please subscribe to Calculus Diaries and give me a thumbs up so that I will continue uploading engaging tutorials on integrals. I thank you so much for watching, and I will see you in the next one. Bye bye.